Okay, so I'll continue by talking about fundamental units. Fundamental units. What are fundamental units? These are the units upon which many other units in physics depend. Okay, to simply put, fundamental units are the units of the fundamental quantities. Just like fundamental quantities exist on their own without being derived, their units, the units that are attached to them, also exist basically without being derived. And these units are the building blocks for several other units that we have in physics. Okay, I mentioned in the previous lesson, part A, that physical quantities are measured based on some predetermined standards. They are handled based on standards, and these standards are referred to as units. Okay, and then there's a generally accepted system of units that is called the SI system of units. All right, used in dealing with physical quantities. What is the SI system? The SI system of units stands for the International System of Units. The abbreviation SI stands for International System. Okay, you may want to ask yourself why is it written as SI and not IS? Well, the abbreviation SI is taken from the French rendition, which is Système International. All right, I beg your pardon if I didn't pronounce that very well in French. But just to summarize, SI stands for System International or International System of Units. What is this International System of Units? This is a system of units used by scientists and engineers around the world to measure physical quantities. What does that mean? There is a generally accepted standard for the purpose of accuracy and, you know, uniformity when dealing with physical quantities. The reason for that is that, take for example, if I'm a scientist in Nigeria and I want to carry out an experiment, I want to work, I'm trying to work on a theory and all that, and I'm dealing with physical quantities, doing various measurements. Okay, somebody else in US, in Canada, in Ghana, in Gambia, anywhere, any other part of the world, okay, who is a scientist too, will also be dealing with similar quantities. So there should be a generally accepted standard so that there can be agreements among engineers and scientists that are scattered all over the world in various parts. Mind you, there are other standards, all right, that can be used in measuring physical quantities. But the one that is generally and commonly used is called the SI system. This SI system can also be referred to as a metric system. Now, the name metric system is like an older version. It's like an older way of referring to the SI system. In modern times, we call it the International System or SI, or sometimes we can refer to it as the MKS system, which is the meter kilogram second system. Okay, so now let's look at the fundamental quantities and their units. The units here we're talking about are their SI units. Recall that I mentioned that there are 7 fundamental quantities, basically, which are building blocks for several other quantities in physics. So here we're going to see their units. Length, for example, the SI unit is meter. Okay, now mind you, length can be measured with other units. Take, for example, you can have length measured in yards, in feet, in inches, in maybe millimeters, maybe kilometers. All those are ways of measuring length. But the SI unit is meter. Same thing goes for mass. Mass is measured in kilogram. Okay? Time is measured in second. Of course, you can also have time measured in hours, in minutes, in days, in years, in months, in weeks. But all those other ways of quantifying time are not the SI. None of them is the SI unit. The SI unit for time is second. Temperature is Kelvin. You can have temperature measured in degrees Celsius, in Fahrenheit, but the SI unit is Kelvin. Okay? Electric current is in ampere. Luminous intensity is in candela. Amount of substance is mole. Okay, so you might be wondering, okay, if there are other ways of measuring these quantities, take for example meters. Maybe I measure length in inches. There are ways that inches can be converted to meter, which is the standard. So every other ways of measuring these units, all right, or measuring these quantities can always be converted to the standard units, all right, which is the SI unit. So for example, if I have time in hours or in weeks, I can convert it to seconds. If I have temperature in Kelvin or in Fahrenheit, sorry, if I have temperature in degrees Celsius or in Fahrenheit, I can convert it to Kelvin to bring it to that standard. Okay, so all the units you are seeing here for these fundamental quantities are the SI units for these quantities. Okay, now we have the unit symbol. Why do we have unit symbols? It is like a shorthand way of, referring to these SI units. Maybe I want to write 1000 meters. I don't need to write the meters in full. I just put the unit symbol there. And these unit symbols are supposed to be correctly specified. Take, for example, meter. Meter is small letter M. So take, for example, somebody can decide to say 2 meters and write capital letter M. Another person decides to write 2 meters, small letter M. The first one is wrong, and then the second one is correct. So take note that your meter is small letter 2M. All right. Same thing goes for kilogram. Your kilogram is small letter K and small letter G. There are 4 different ways this can be written. The first one, capital letter K, capital letter G. The second one, small letter K, capital letter G. The third one, capital letter K, small letter G. And the fourth one, small letter K, small letter G. Of these 4 ways, the first one is wrong, the second one is wrong, the third one is wrong, but the fourth one is correct. So you must know how to correctly specify the symbols of these units. So if I want to write 3 kg, I write it as 3, small letter K, small letter G. Same thing goes for second. Second can be written as 2, S with capital letter, or 2S with small letter. All right. The correct one is the second one. Seconds too can be written as SEC. Okay, SEC. Okay, 2 sec. Now this figures the figure 2 here is not, this is not only peculiar to the figure 2. It can be any value. It can be 1000, 7.5, 1 million. Okay. Now your temperature is Kelvin, capital letter K. So in specifying that Kelvin, you write it as capital letter K and not small letter. So if I write 2 Kelvin, small letter, 2 Kelvin, capital letter K, all right, the first one is wrong, the second one is correct. Kelvin is capital letter K. And then same thing goes for your current, amperes, all right. If I want to write 3 amperes, I don't need to write the ampere in full necessarily. I can just use capital letter A to represent it. Candela is small letter C, small letter D, and then amount of substance is MOL in small letters. All right, so these units must be appropriately specified and written. So these are the SI units for the fundamental quantities. And it is from these SI units that these fundamental units, they are called the fundamental units now, that other units are obtained. In the next lesson, part C, I'll be talking about derived quantities. So do well to subscribe, also turn on the notification button so that you can get alerted when the next lesson is updated. Thank you very much.